Okay, so we'll get started here in just a minute, but while we're waiting for some other people to join, let me work for me. Okay, here's a couple things if you haven't seen them. There's a YouTube channel. I need to get the new channel up. If you go to youtube.com/agilelnl, that's where we put most of these talks. This channel has Agile cartoons and various things like that. Also, if you're interested in a copy of my book, there's the URL that will get you a PDF of it. That will also put you on this list. So if somebody wants to get these invites, they can sign up there to get it. Upcoming talks we've got. On the 18th, we're going to be doing an introduction to what is Agile. That's going to be a lot of fun. It's a very good either refresher, or if you've got some people you work with, like, hey, we want to just all get on the same page, we're going to go through each Agile principle and usually have a story or something interesting about it to help us remember it. The 25th, Klaus Leopold is going to be joining us to talk about flight levels. This is a lot about how to make not just a team Agile, but make an organization function in an Agile way. I don't know much about this, so I can't tell you a bunch, but it's going to be a lot of fun. Looking forward to that. I'm excited to have him here. And then on the 1st of November, we're going to be talking about extreme programming. Then we're going to, George Dinwiddie is going to be talking to us on the 15th about sustainable test automation. Pratik's going to be joining us on the 29th, talk about Ford's frameworks and Toyota's theories. And then we've got another, let's see, trying to remember who's going to be here on a dynamic routing, talking about that on the 13th. So exciting things coming up. You can go to events.xeric.net if you want to know more about any of those or get them on your calendar. Okay, start off question here. In the book Pinocchio, who was the cricket? Now we're going to have some literature-based questions here, and it'll make sense as we go. So the link's in the chat, or you can just type it in. But in the book Pinocchio, who was the cricket? So B, if you click on that link, you'll be able to get your information to show up here. We've got a friend of Pinocchio that travels with him. Looks like we've got 100% people saying that. Any other votes? Everybody's voting B. Or a bug that gets killed by a hammer. Get a few more results in here. So the interesting thing about this question is the only answer up here that is wrong is B, a friend of Pinocchio that travels with him. That is the Disney version. In the book, Jiminy Cricket shows up, about page 3 and is immediately killed by a hammer by Pinocchio. And then he shows up as a ghost and kind of haunts him, telling him to do better things later on. Okay, so another question here, just to get us all warmed up. What does Peter do in, let's see, Peter Pan. Yes, stumbling over my words. What does Peter do if the Lost Boys seem to be growing up? Does he send them to be pirates? Does he take them back to London? Does he kill some of them off or turns them into trees? Got one vote here for turns them into trees. I will add the link here again in case anyone else is joining. Okay, so these all seem like probably valid answers, except the book actually implies that he kills some of them off, but many of them escape, and as they grow up, they become pirates. So children's literature is a lot different than our Disney versions of it, evidently. Okay, so here's our plan for today. We're going to be talking about sizing work. Then we're going to be talking about estimating, like what that looks like, and then talking about forecasting. So that's kind of a big outline of what we're going to be looking at today. So let's talk about sizing works first. So I was looking for an idea, and you may guess what we're going to use for sizing based on the questions we've just had, but what's something we can think of to kind of get us thinking about sizing in a way that's not what we're used to seeing every day, because maybe that'll help us come up with ways of approaching forecasting and estimating that we might overlook otherwise. So we're going to talk about sizing when it comes to books and look at how we could predict that, and then look at how that can relate to the way that we predict things in software. Now, this is not a completely hypothetical example. This is my daughter, let's see, this was 7th grade, and this was her reading assignments for one class. So we homeschool, we've got a very book heavy program. So the question of how long it's going to take to read books is something we've actually talked a lot with as a family to try to make sure we're on track for getting things done. So let's consider these books, okay? So I've got these books right here, and we have, let's see what in the order we've got. Alice in Wonderland, which is a great book. If you haven't read as an adult, I encourage you to. Peter Pan, Pinocchio, The Divine Comedy, Robinson Crusoe, and Moby Dick. Okay, so I've got all these books here. This is what they look like. It's great books to read. So let's say that we're in a situation and we've read Alice in Wonderland, Peter Pan, and Pinocchio. Alice in Wonderland, Peter Pan, and Pinocchio. So what percentage of our reading list is complete? So is it 19%, 33%, 50%, or all of the above? And there's not necessarily a right answer here, a wrong answer, but just your gut instinct of what you think is complete. So we got some votes for 19%, 6 books, 3 of them are done. A lot of people are 50%, which is completely reasonable. Probably D, people saying this is a trick question. It's probably none of these if he's putting these up here because he tricked us on that one with Pinocchio earlier. So all of these are, you could make a case for any of these, right? 19%, 33%. There are ways that you could come up with any of these options up here. So let's look at, what I want us to do is kind of talk through what that would look like and then think about how these principles will apply to when we're trying to size our work for Agile projects when it comes to stories. So 3 of 6 books completed, that would give us 50%, right? So that's perfectly valid way of doing it. But if you notice by looking at these books here, these 3 books that we've completed are a lot easier to hold than these 3 books right here, Divine Comedy, Robinson Crusoe, and Moby Dick. So maybe that's not the best, maybe just the number of books is going to mislead us. If I read a whole bunch of books this size and leave all these to the end, I may think I'm almost done, but all the hard stuff is still there. Oh, I see, having a green book wasn't the best choice there, evidently. But okay, so what's another way we could possibly do it? How else could we measure this? So type in the chat, what's some other ways we could measure how long, the size of these books, other than just counting the books, what could we do? Number of pages, it's a very, very valid way of doing it. Pages, definitely. Number of pages, weighing them, I like that. We could actually weigh the books. The reading level, that's a good point. That's something we might want to kind of consider as part of this. We'll look at the sentences a little bit later. There's a huge difference between a sentence in Robinson Crusoe and a sentence in Peter Pan. So these are all number of words. These are all very valid ways of doing it. Well, here's another one. What if we were to measure them, right? Kind of similar to weighing it. We're going to measure them and we can say, okay, well, Alice in Wonderland is 2.5 centimeters. Peter Pan is 2 centimeters. Pinocchio is 2.5. Divine Comedy 6. Moby Dick 4. Okay, well now we're somehow representing, we can see that we've done the ones that are really short, right? These are a lot thicker. Now it could be different depending on the size of the print on the pages, but there's kind of a upper limit or a lower limit of how small you can make things before people can't see them. Type of paper, that's a good point, right? Some of these, if they're really, really thin paper, like you have in Bibles or something like that, they might be a lot thinner. But in just looking at this would say that we've read 7 of 21 centimeters. So we're 33% complete. So that's another valid way of measuring this. We could also look at chapters, right? We could say Alice in Wonderland has 12 chapters, Peter Pan has 17, Pinocchio has 36, Divine Comedy has 100 cantos, whatever that is, right? It's kind of like a chapter. Moby Dick has 135 chapters, and Robinson Crusoe has 31. There's a lot of variance here, but if we were to measure it like that, that would say that we're 19% complete by doing 65 out of 331. That might be more accurate, maybe. Another idea is, what if we were to count the sentences? Well, that might work in some ways. That might be an interesting statistic. But here's the first line from Peter Pan. All children, except one, grow up. Which I love that opening line for a book. Here is a single sentence from Robinson Crusoe. That is one sentence from Robinson Crusoe. Okay, so if most of Robinson Crusoe is like this and most of Peter Pan is like this, our sentences may mislead us a lot. And as somebody mentioned, this is going to be a lot harder reading level to do this. I like this question here. How much value does each book add? Your percentage should be the percentage of value added. So that's a good idea. I'm wondering how you would consider that. You only know after you finish reading it what value it had for you. Okay, so this is in the books that I'm talking about are kind of within the context of homeschooling, so there is some value associated with it. Maybe what if we count the words? Well, would it be worth counting each word in the book before we read it? And this brings up an interesting point that I think is very important when we're thinking about how to size stuff, that how much should we invest in non-reading activities to create a better estimate? And if we had to go through and count every single word or every sentence in the book or every character in the book or something like that, we start coming into a situation where at some point we'd be better off just spending the time reading the book than trying to figure out exactly how long it's going to take. How much should you invest in estimating software before it starts being counterproductive? And I think this is a really important point to think about is we want to estimate just enough that it's useful or we want to size just enough that it's useful, but not go so much into sizing that time would be better spent actually doing the thing that we're trying to do. Because if we're taking away time from actually developing the software and we're coming up with more accurate sizing, but past the point that it gives us any useful information, at some point that starts being counterproductive. So you want to think about when you're sizing stuff, or books or software or anything, at what point, what do I need to use this information for? And at what point is it that I've got all the information that I need to make a good decision, and any attempt to capture more fine-grained information is actually just going to be wasting time. Everything is going to have trade-offs. So let's think about some principles for sizing work here. So the units used for comparison need to be similar. That's when we're looking at the sentences. If we compare the sentences that are like 5 words long with sentences that are longer than most of us write paragraphs, those aren't going to be the same. So that's going to make us, not that you can't have some variance in what you're comparing, but if you've got things that are just completely dissimilar, it's not going to let you make good decisions about what you're doing. And sizes must be inexpensive to obtain. If the cost of obtaining the sizing takes away from things that you could invest in actually reading the book or actually delivering the software, at some point it's not worth doing anymore. So it needs to be fairly inexpensive so you can get your sizing information quickly and make decisions on that. Because our goal with a book or software or anything, our goal is not to know how big Moby Dick is compared to other books, right? Our goal is not to understand how big Robinson Crusoe is compared to Peter Pan, like knowing exactly how big it is. Our goal is to actually read the books. If we're creating software, our goal is to actually create the software. And we want to make sure we're not getting to the point that we're detracting or taking away from the thing we're actually trying to do because we get so focused on sizing. When it comes to the units used for comparison, the Odyssey and the Iliad both contain 24 books. So in that case, we probably wouldn't want to use the word, we'd want those to be compared against chapters because that's more how they are to us. So what some people will call a user story, others will call an epic. And we've got stuff like that shows up in software as well as books. Time spent determining size could be spent doing actual work, like we mentioned. Okay, so let's think about pages. That kind of emerged as being something kind of reasonable. These books are similar sizes in dimensions. Different thicknesses. The pages are what's different. It's not like we've got one book that's 5 feet across or something like that. So maybe pages makes a lot of sense. It's easy to estimate, right? They're somewhat similar in size. If I look at both of these books together, so I know that Alice in Wonderland is a lot easier to read, a lot smaller than Moby Dick. And so maybe these are, but the number of pages in them, the paper when I look at it is similar. By counting pages instead of measuring it, then maybe it doesn't matter if Moby Dick, the pages are a little bit thinner. If I'm counting pages, maybe that it compensates for that. So this looks like the perfect balance of trade-offs, like how many pages are in the book. We can look to the back. We don't have to count every sentence. We can look to the back, know exactly how many pages are in it. That seems like a really, really good way to measure things. So how would you size books for producing an estimate? So everything we said, there's no right or wrong answer, but just looking at what's up here, I probably should ask this question first, but characters, words, pages, inches, and by characters, I mean like the individual letters, not necessarily the number of characters in the book. Inches, chapters, number of books, weight, audiobooks playing time. I know this is something I've used a lot to get an idea of how long it's going to take to get through a book. It's just if I was to read this out loud, how long would it take to get through it? So, and in modern times, it's pretty easy to get know the number of words in a book, right? We've got, usually you can find that somewhere. But if you've just got the book and no resources online to look up, you may not be able to find that quite as quickly. Okay, so range of things. These are all very, very valuable, and in different contexts, probably most of these would actually make sense to do. But I left something out that's very, very important. I forgot to ask, what does it mean to finish reading something? If we don't answer this question and use it as part of our sizing, we can come up with stuff that that can end up creating lots and lots of hidden work for us. So finishing reading means there's no hidden work. So is there any type of validation? Well, in the case that I'm talking about, we actually have things that are chapter or section tests. Now, this actually changes everything, right? Because our unit of thinking about sizing stuff, if we want to be able to say how quickly are we finishing things or what's the rate that we're finishing things, we need to do our sizing in some type of scale that lets us actually say that we're finished with it. Because just knowing how big things are, what we really wanted to do is be able to know how rapidly are we finishing things. So let's look at this. We've got principles for sizing work. We talked about units must be used for comparison that need to be similar. Sizes must be inexpensive to obtain, but it can also be completed with no hidden work, or with as little hidden work as possible. In the case of what we're talking about here, we've got chapter tests, or something that happens at the end to make sure you've actually done the work you needed for that chapter. Chapters, so if that is the case here, then chapters are probably the most appropriate unit of work size in this case, because it allows us to follow all three of those principles. And so yes, it's that becomes our definition of done. We're done with it. Now there still may be a test at the end over the entire book, and maybe there's not as much we can do about that. So there's still some work there when it comes to the books, and maybe software will be something similar. But you want to make sure you've got as much work done of saying, yes, this is actually complete and finished. So if we look at that, we would say that we're 19% done with these books. So pages might be more accurate, but the chapters are tied more to the way that we deliver. So when you're thinking about software, what is the thing that looks like, what's the equivalent of software for us? So here's some different ways we could size software. Like we could say we're going to estimate the number of characters it will require to deliver this piece of software, and then see how many characters we're producing toward that. That sounds crazy. I actually have seen some estimations that actually use the number of tokens or the number of words, and they were trying to estimate on that. It's been a very long time, and I don't think that anyone's really using that anymore, but that was something that people did at one point. The lines of code. I've seen places where it's like, we think this will be this many lines of code. It takes us this long to produce line of codes. Function level estimates, how many function things will be in it. A lot of these are like, much, much older when people were doing things on cards and stuff like that. But these are ways that people would estimate. Features is a more common way for us to estimate. Epochs is another. So question for you, what unit do you use to size work? And use a single answer, or put a dash in it, or an underscore in it. Otherwise, it'll break it up in two, and then people get confused. So what unit do you use to size your work for software? And there's no right or wrong answer here. See what people are. Story points, features, hours. And oftentimes when people are using story points, there's a fly around here, sorry. When they're saying story points, it eventually comes to some type of translation into hours or days. But it looks like stories is kind of the level most people are working at. We've got hours, features. Let's see. Story points. Depends on the need. Sounds valid. Okay, so lots of different ways that people are doing things. None of these are necessarily wrong or more right than others. These are different ways and I see complexity on here as one that people are using. And the big thing of whatever you're using is making sure you're actually getting value out of it. But if we think about all the different ways we could estimate stuff, and kind of graph it out here based on how granular it is coming this way and how hard it is to obtain on the up and down, trying to create a really detailed, useful 10-year plan will take a long time if it has enough detail to really be super useful and is a really high level plan. Epochs take a lot less effort to come up with, and they're more granular. And then we come down here in features. which probably will take less effort because it's a smaller thing to figure out what it is. And then we come over here and then we start going back up again, right? We've got points, coming up with points, pretty easy to obtain. Maybe they're more granular classes, easy to obtain, but now we're starting to become harder and harder to actually obtain as we go on up, because you have to know so much about it to figure out how many characters there are, the number of lines of codes or functions. And this is just rough, and we could argue about where these things are, but I thought it was interesting that if we kind of think from going across granularity, there's this U-shaped curve right here. And so I was asking myself, what's right here? Like, what's kind of at the bottom? What's something that's, where's the sweet spot of it being not too granular, not so detailed and not too big, but it's pretty low effort to obtain. And usually that's going to be the thing that we call a user story. Now, user stories, just like books, can be really, really big or really small. There's lots of variance in how people actually use things. But if a user story is something that's small, it's about the smallest thing that we can say is valuable to the user, that we can demonstrate to the user, that's probably going to be about the sweet spot, right? It's the smallest thing that we can say, this is actually done, I could actually deploy this, and the user would say, my life is better than it was before you deployed this user story, which means you can actually demonstrate it to the user. It also means it's going to have to be something that's usually going to be full slice, right? Because you can't just say, here's the UI, but you can't use it for anything, or we did all this work in the database. So that brings us to thinking about estimates. So we talked about kind of how to size stuff. And for the purpose of this talk, we're going to say story points seem to be the sweet spot for where we're looking at. But now let's switch and start talking about what it takes to actually estimate things. So another literature question as we're going, because that's our theme here. What takes its name from Moby Dick? Question for you. Let me add this here again in case it doesn't have it. The Grateful Dead, the band. Great Dane breed of dogs. Starbucks, the coffee shop. Or Green Bay Packers sports team. What do you think takes its name from Moby Dick? So the only one I know of here that takes its name from Moby Dick is actually Starbucks. He was the, I think, the first mate on the ship. I'll have to look that up. I don't remember now. But yeah, Starbucks was one of the characters in Moby Dick. Grateful Dead, not sure of. Great Dane, I like the idea, but I don't know that it's there. No one thinks the Green Bay Packers. Evidently, everyone knows that they were, I think they were meat packers, right? They were in Greenway one time. Was like, what is a packer? But okay. So let's look back at our example here. 331 chapters. So let's think about how would we actually estimate. We could say, how long does it take to read an average chapter? Well, let's go through and let's go through the estimation process. And the reason we're going through and thinking about books is there's lots of stuff we probably do for software that if we stop and look at how we would do it for books, it may give us some aha moments. So how would we estimate something like this? Well, how long does it take to read an average chapter? Well, if I've just got to guess the number, I would probably guess at an hour. I don't know if it's any better or worse than anything else, but let's say it takes an hour. Well, how long does it take for each test? Well, let's say the test takes 30 minutes to complete. Okay, so if we've got 331 chapters, then we say 331 times 1.5 for an hour and a half equals 496.5 hours. Now, just as a side note, I have arrived at a very, very precise number here, right? This is an extremely precise number. But if I ask myself how much confidence I have in this number, it's very, very little, right? I've just made up some things and threw it out. I'm estimating. I'm just saying this is probably about how long this will take. I'll just guess. So do I have any evidence these numbers are better than a guess? Maybe. Maybe I've read some books before and I'm like, an hour seems about right. Now, another question that's very important is, do I know what happens if I fail a test, right? If I fail a test, do I have to reread that chapter? Do I have to start over at the beginning of the book? What actually happens if I do this? And then we also may be asking ourselves, just how difficult is the Divine Comedy, right? That's a pretty thick book. It looks like it's got big words in it that I may not understand. How difficult is this going to be to read? And then I may also ask myself, can I read it in English or do I need to learn Italian before I start actually trying to read it? These are all very valid questions that we might need to know for this estimate. Other important question is, what are the repercussions if my estimate is wrong, right? If this is going to carry through and this estimate everything is based on this estimate for the next 9 months of school or something, this may be there may be very catastrophic consequences if this estimate is wrong. So then we do something like this. I'm sure no one has ever done this before. Maybe I should just triple the estimate to be safe. And so we end up with 1,489.5 hours. Once again, we've got a very, very precise number here that implies we know a whole lot. The precision of this number implies that we know a whole lot more about what's going on than we actually know. So have you ever done something like this for software? So give me a thumbs up. There should be a thumbs up at the bottom if you've done something like this for software before. Got some people that have. I know I've done stuff like this before. This is a very common way of approaching estimating, or something like this. Back in the late 90s, I was taking some project management classes, and they basically gave you something that looked similar to this. It was basically the idea that you were going to do something like this. And I like Tom's comment here that precision time implies finality. Giving a number that's like really, really, really precise does say so, and that's not just a psychological thing, but if I tell you that this ball bearing is 1 centimeter around versus a ball bearing that's 1.0000000 centimeters around, the precision that I am specifying by having more zeros is huge, and the cost is probably a huge difference as well. I've padded, but not that much, okay? So it feels like this isn't very accurate. And it's even worse than that, because books are very well defined, but software is not, right? There's another problem with estimates. So, missed a point here. So books are very well defined, software are not. When you're reading through a book, it's unlikely that somebody's going to be sticking in more chapters at the end of it, or rewriting a chapter while you're in the middle of it. You don't usually read through two chapters and then find out that the author says, hey, you know that first chapter, I've changed it and I've renamed all the characters. You need to go back and reread that because it's not what you were expecting it to be. Software is not like that. Software does change. So that makes this even harder when it comes to estimating. But there's another big problem with estimates as well. You have probably heard of Parkinson's law. It says work expands so as to fill the time available for its completion. And Parkinson's law actually was a military person. I can't remember what level he was, but his name was Parkinson. And he wrote a book of these types of laws. I haven't got a copy of the book yet, but there actually is a book out called Parkinson's Law with these types of observations in it. But estimates create expectations for managers, and estimates create expectations for developers. So when you're dealing with an estimate, often what happens is it's very easy for something that you estimate and say, well, this is going to take 5 days. It's very easy for it to take 5 days, even if it could have taken 3 days. What happens in a lot of cases is you end up thinking you're further along than you are, and you end up not being able to fix it into the time box because the work just naturally expands so as to fit the time available for its completion. And when we think about an estimate is really a guess at the point where we have the least evidence available. An estimate is a guess at the point where we have the least evidence available. So wouldn't it be better to guess after we had some evidence? And we kind of talked about that. Maybe we've read a book before and we think an hour is a reasonable amount of time. But what if we could create a process to refine our guess each week based on our actual experience? And that is what forecasting is. Forecasting is where you're taking your information, and as you go, you're changing what it looks like based on the actual evidence you have available. As you acquire more evidence, you update what things look like based on what you've actually experienced. And this, if you think about the way that we had Dan Buchanan come and talk, and he showed examples of hurricanes and showing how they'd say, here's the hurricane's coming like this. It's going to hit somewhere here. And then the next day, the hurricane's right here. It's going to hit somewhere here. And as they gradually move up, as time goes by, they refine their forecast of here's where we think the hurricane is actually going to be. Okay, back to our literary theme. In Alice in Wonderland, who did the dodo bird represent? Was it King George, Alice's father, Lewis Carroll, or Charles Dogston? So which one of these did the dodo bird represent? King George, Alice's father, Lewis Carroll, or Charles Dogston? And C and D are both correct answers, although D is probably a little bit better of an answer. Because the reason that Lewis Carroll, his real name was Charles Dogston, used the dodo bird to represent him is because he had a stutter. And so when people ask him his name, he would say Dogston. And so he thought a dodo bird would be an appropriate character to represent him in the book. Anyway, fun trivia. Okay, so back to forecasting. What if we could use evidence-based numbers? So what would it look like to try to do forecasting based on the chapters read? So take a look at this spreadsheet. And here we've got weeks going down here. So here's each week, right? Going down. We've also got the total number of chapters, right? We've got 331 chapters to read. And then we've got another column here that says how many chapters are actually remaining. And that's calculated by taking the completed and subtracting it from the total chapters. So here's the remaining and total chapters. Over here, we're going to just guess to start with how many chapters we think we can do per week. And we're going to come up with a high guess of saying we think we can do 8 a week. And we're going to come up with a low guess of saying we think we can only do 5 per week. Then we're going to actually do this for a while. Then we're going to calculate out based on if we can only do 5 a week, when would we finish? If we can do 8 a week, when would we finish? So we've got a range here, an early forecast and a later forecast based on this range right here of saying that it was going to be between 5 and 8. So then we come over here, we've got our completed. When we complete 10 in this week, then we subtract those from the number of remaining stories, and we've got 321 remaining chapters to do. I'm jumping ahead to the software side of things. So these numbers right here are simply a guess, right? This is just a guess. We have no evidence that any of this is remotely accurate, but we've got to start somewhere, and we're saying, I think I've got 5 to 8 hours worth of time to read a week. I'm thinking it will take me about an hour a chapter. I'll go ahead and just plug these in to start with. But notice what happens as we start gathering data. We've now got different numbers down here. And what we did is we looked over here and said, okay, on my best week, or on my worst week, I did 9. The 2 worst weeks, I did 9 and 10 chapters. Okay, let's average those. And we'll say that on average, our low average is going to be 9.5. And then we also come over here. I guess I've got arrows for this. And we say on our best week, the green ones, I did 15 and 12. So we'll average those and say 13.5. Now, if we keep doing this and keep updating as we go, this range right here will probably narrow over time, or at least it could expand if our low and high starts getting further and further apart. But this gives us a way, kind of like thinking about where the hurricane's going to go, to think about, okay, based on what I know now, where is it going to be? Based on what I know now, where is it going to be? And moving through that. Yes, I like some people saying this looks familiar because I've used this with some of you before. So what types of events are included in this forecast? And this is one of the big differences between estimating and forecasting, because when it comes to estimating, you're often trying to figure out what types of things could potentially happen. And you're having to think about those. With forecasting, you're trying to think more in terms of what type of events have happened. And as long as the things that have happened in the past are somewhat similar to the things that might happen in the future, our forecasts are going to be reasonably accurate, or at least take into consideration the types of things that might happen. So when I think it was when I first did this talk or started working on it, we were actually living in New York. We were on Wall Street. And so I was going to work at the Federal Reserve Bank there every day. And my wife and kids were at home doing their schoolwork and reading and stuff like that. Well, one day we had something. So types of things that could throw things off are, electricity could go out, right? They could have to, one time somebody saw some batteries from a motorcycle, didn't know what they were, called it in as a bomb threat, and they all had to evacuate the building. So all these things are going on, those types of things that if you're doing a estimate, you're trying to think about what types of things could happen. If you're doing a forecast, those just get built in. Another thing that happened one time is Verizon went on strike right outside our window. And so I don't think I've got the sound playing on this, but this was right outside our window. I should have got the sound set up. This was extremely, extremely loud. They were all very, very polite, but there was a whole bunch of noise, which tended to impact your ability to read when there's people out there beating on drums and honking horns and stuff like that. those are the types of things that just happen in life, right? In your software, there's stuff that's just going to happen. When we look at the forecast, though, those types of things are built into the numbers that we're using because if things could happen in life, they're going to happen. They're going to be part of that range that we're building into. So when it comes to software, okay, so that's when we're thinking about estimating for books. Software is a little bit different, right? And have you ever tried to read a book while someone kept adding chapters to the end or changing chapters earlier? Books are usually well defined, but software is not. So have you ever had someone add stories to your backlog? And most of you would probably say yes, right? That's very, very common. People are going to add stories to the backlog. Things are going to change. Hopefully they take stories out as well. So software is usually not as well defined. So how do we model this? Well, let's look at another spreadsheet here. This is about the same thing as what we just looked at, but we made a small change here. So not only are we keeping track of what we've completed, but we're also adding the number of stories that we've added and our net progress. So on the first week here, we completed 10 stories. We made a net progress of 10. We didn't add any stories. On the next week, we added a story, right? We completed 13 stories, but we added one story. So our net progress in this case is 12. We made 12 steps toward being done. Even though we completed 13 stories, we added one. So our progress toward getting toward 0 wasn't the 13, it was actually the 12. And this is a very important thing because a lot of times I see teams using the original number they started with and measuring their progress toward that instead of what the world looks like right then. And on the stories added, we could also throw stories out. But here we did something similar. We said, how much do we get done? Well, between 1 and 3. When we got down here, we look at what we've actually done, and we created estimates based on that. And we'd continue to do that. In this particular case, we got 15 stories done, but we also added 15 stories. We made 0 net progress that week, right? We didn't get any closer to actually being done. And it's interesting to see how this shows up here. We thought the earliest we could get done was October 21st to January. When we got down here, that's all just bumped back a week, right? Everything moved a week in the future because we're still using these estimates. But if we get enough of these zeros in here, we're eventually going to change what we're using as our estimate or as the estimated number of stories we complete per week, and our view of it will become more accurate. And there, oh, okay, I just pointed through all those. Okay. So from that, you can calculate stuff out. This is what's happening on that chart of saying, okay, if we have a net change of 3 a week, it's going to take us 97 weeks. We're going to finish in May 11th, 2014. If we have net change of 6 a week, it's going to take us 49 weeks. Here's when we're going to complete. And these are really easy to do in Excel. One thing I found about having these types of spreadsheets, particularly if you go and explain to management, here's what this means, here's the numbers we're using, here's where we've been, it's a lot easier for management or you can tell a much better story about where you're headed if you're including where you were last week and the week before that and the week before that. It's a lot easier for management to have an idea of where you are if you're like, hey, we used to be at this range here and it's narrowing. We're getting closer and closer. It looks like we're going to converge on this state. If we're able to narrow our scope, maybe we can bring that forward. Or as we go, we keep adding so much work that our range is getting wider and wider and wider because we really don't know what the scope is that we need to finish here. If we were to graph that out, it looks something like this, right? At this point right here, I'm saying, here's where I want to get done, but our range is letting us see that there's a really wide range here. As we move forward in time, that range kind of narrows, right? And we get down to the point where we've got a better idea of where these things happen. And these numbers right here, the net change, that should become more accurate over time. So those becoming more accurate should mean that it brings in. So this should narrow not just because it's moving in time, but also narrow because you've got better accuracy of here's the range of how much we can complete in a week. And George is saying his experience with the burn-up chart communicates better than a spreadsheet of numbers. And I think burn-up charts are great as well. I've been in situations where the spreadsheet launched conversations that would have made it easier for the executives to understand the burn-up chart. But yes, lots of ways to communicate. So now let's talk about hidden work. So hidden work is the bane of accurate forecasts. So I guess I threw these in randomly. So keep that in your mind. Think about where your hidden work is while we answer the question, who leads Dante through hell in the Divine Comedy? Is it Beatrice, St. Paul, Virgil, or a wolf? Or a wheel within a wheel? And yes, it looks like we are converging on Virgil the poet actually leads Dante through hell in the Divine Comedy. Virgil was one of Dante's heroes, and so he wrote him into the story to lead him through through things. Okay, so have you ever been in a situation where the last 10% takes 90% of the time? So if we graph that out, it looks something like this, right? We think we're going to get here. Forecasting only works if the future looks something like the past. If the future looks entirely different than the past, I mean, we all want something like this going up. But if we have something where we're like jump up like this and then it takes a really long time, our forecasts aren't going to be accurate. So what would happen if I wait to take the first chapter test until I've completed the whole stack of books? So imagine my kids read through this whole stack of books and like, okay, now let's go take the chapter test. So the test might show me I need to study things in more detail, or it might show me I don't need to study as much. If I do something like that, I could end up with a graph that looks something like this. Lots of progress, read all the books, I just enjoyed the books. Then I start taking the chapter tests and realize that I don't know enough to actually complete these tests. I need to go back and take notes on who the characters are. I need to look for the metaphors that are presented, all these other literature things that I didn't realize I needed to do. Well, then I slow down, right? Because I made great progress in reading the book, but now I'm having to go reread all those books to do the work I could have done at the time. If you worked with software, you've probably seen something like this, where you're hearing, I'm going to do all this stuff. I'm going to write code, lots of code. Or like, writes lots of code, make great progress. Yeah, we're almost done with everything. And then I try to deploy. And I come in here and everything slows down, right? Or I get into this place where every new feature starts breaking something else. And so it just slows down and slows down and slows down. So we need a way to measure all the way through. We need to build the ability to change into the process, particularly when it comes to software, because we know the software is going to change. So let's look at kind of some principles for forecasting, right? We need to measure all the way through, meaning we need no or as little hidden work as possible. With the books, it's the idea of doing the chapter test. With measuring all the way through, it probably means we need to take all the way through to a production-like environment at least. If you've got lots of change management controls around production and you only deploy locally on people's computer, there's a huge amount of hidden work involved in actually getting that all the way through. You need to build in the ability to change. Often this means investing heavily in tests. So if something does change, you can make the change to that while proving the rest of the application does what it's supposed to. And use the past to forecast similar things in the future. Don't expect 4 weeks when the team is fully dedicated to predict how much you're going to get done over Christmas break. Now, if you're using times that have different holidays in it to predict other times that have holidays in it, you're probably going to be fine, but you just want to make sure you're not setting yourself up with a past that looks very, very different in known ways from what the future looks like. And here we're back. Let's go back now to our principles for sizing work. So units used for comparison need to be similar. Sizes must be inexpensive to obtain. And it needs to be something that can be completed without any hidden work. So back to these two things. So these are two things. So these are the summary slides of kind of what we're looking. So principles for forecasting, measure all the way through, build in the ability to change, use the past to forecast similar things in the future, and the principles from the beginning of sizing work. Make sure units for comparison are similar. Sizes need to be inexpensive to obtain, and you need to be able to complete it without any hidden work. Okay, so that covers what I've got on the slides for today, but I wanted to save some time at the end because this is something people usually have a lot of questions or comments or even better ideas than the things I presented on. So kind of open it up. Any thoughts, concerns, ideas? What do you think of this? Does it sound useful? I've got to read what we've got going on in the chat here. Any thoughts or comments or questions on this? Or ideas that you've seen work well? And one thing I will mention, the stuff I showed you with the spreadsheet is a very simple way to forecast that. You can use Monte Carlo simulations that actually run random. Um, they simulate what happens with different story sizes. Those are very, very useful as well. I found they're a little harder to explain. This has been very, very useful in a lot of contexts. So I'd say try starting with something like this. And if you want those spreadsheets, let me know and I'll forward it to you. Terrence, did you have a question?
Yeah, just quick question. I'd like to get thoughts from yourself and other team members. When people are looking at estimating, one of the things that we have a tough time with, I think, is understanding if a risk or an issue is going to be something small or something big, right? And that can have a dramatic impact on the estimate for either that feature or even at a story level, right? Just want to know if you had any thoughts on, how do you go in there and sort of identify, okay, we know we need to get, I don't know, let's say a server set up or something that we haven't done before set up. Is that going to be a big deal or is that going to be easy, right? And therefore, how do we build that in?
So a couple thoughts. One, if you're working with a small unit of something, usually that helps minimize that risk a little bit. The other thing is if you want to make sure you're not starting off with Peter Pan and leaving Divine Comedy till the very end, right? If you've got something that's really risky, you may want to bring that forward so you can actually get that experience. If you wait till the end, and if I was working with a team one time and they were making great progress moving forward, and then we found out, they weren't really sure we were going to be allowed to deploy the database we were using into production. Like they may be prevented. Like, that's kind of a big risk, right? Maybe we need to get production stood up and try to do it to make sure we're allowed to do it or we can do it. So smaller units of work is one thing I would suggest. The other thing is think what you're doing to bring the risky things forward. Bring the unpleasant things forward so you get to experience those early. And then if you are using forecasting or something like that, you'll probably be in a situation where some of that risk is built in, and hopefully as you move on through, you get less and less risky things, but you're starting from a place of saying, here's the worst that could happen. We found the worst thing that we could possibly work on because it's really, really risky. We did that and it took this long. If you're using that to forecast the next piece, you're probably in a better place than we took the easiest thing possible and we're going to use that to forecast this other thing that we have no idea how to do. So those are some thoughts. Anyone else got any other comments for Terrence? I'll tell you, if you think of something, put it in the chat. And I see that we got another hand up. Thanks, Terrence. Was that helpful? Was that okay?
Very helpful.
I see we got another hand up. Was that you, George?
Yes. Yeah. So one comment on this. My experience is that the business doesn't really care about user stories. That's not the right level of granularity for them. So I prefer to go with named features.
Okay.
And use that as the basis. And here's an old blog post of mine that talks about this. Now, that means that you do have to then ultimately, come up with some sort of estimate of how many stories are in the feature. But you learn that over time, and you start thinking about, well, how does this feature compare with other features we've done in the past, and in terms of size and complexity and difficulty. Another point though is that delays can be very nonlinear and often outside of your control, outside of the team's control. And they can swamp out the actual work in terms of your estimation. Now, so I don't like to build delays into an estimate because then it hides them. And it leads you into Parkinson's law. I think they need to be put into the plan, and plans are built on estimates. They're not the same thing. Too many people say, "Oh, you estimated we're going to be done. It's going to take this long. Therefore, we're going to be done that period of time from today," and that's not a very good plan because
right.
You don't know what's going to delay you, but there's always something that delays you. Very rarely do things happen faster than you expected.
You raise an interesting point. I want to make sure I'm understanding it. So I think you're saying that when there are delays, the thing I was suggesting is that the things that delay you over the course of time, if you know how long things take, those will include delays if you use that to say, here's what things are going to look like in the future. And I think what you're saying is the delays often are so lumpy, it's not helpful.
Yeah, it can really fool you. So I mean, there things taking longer to do. I don't call that a delay. It's oh, we estimated this is going to take this amount of time, and instead it took us longer, or it might take us shorter. But delays like, oh, we had a question about this, and it took the business 3 weeks to get back to us on it. That's something that's completely out of your control, and it can really mess things up.
But if I have 12 weeks worth of data of small similar sized stories that I'm moving through, it seems likely to me that a similar number of the stories in the next 12 weeks will have similar delays of getting stuff from business from the time I started trying to work on this until I tried to do it.
That's not my experience.
Okay.
It
Okay,
depends
cool.
on what the question is you've asked the business.
Okay.
So, and then things like you talked about the Verizon going on strike, and that causing basically delays, interrupting the work of reading and causing delays. You're not going to think, oh, what if there's a noisy strike going on outside the window? But you can think, well, there's always something that slows stuff down, and put into your plan a buffer for that. And then you can all separately say, well, how are we doing on our buffer for our plan? So tracking your progress is one thing, as you go, but then tracking how well the plan is doing is sort of a separate calculation.
Okay. Cool. On the features versus user stories, when I'm using user story, I'm using to represent the smallest thing I could put in production for the user that they would say, thanks, that made my life better. Is that how you were using it too?
Well, so I slice user stories smaller than that, because my feeling is that a user story should it's best if they take around 2 days or less to accomplish. Team days, not necessarily person days, but and so it may take multiple of those to get to the point of something that you would actually want to put in front of a real user. But you can put in front of a proxy user to say, or is this part working the way we want?
Right.
But the business typically wants to batch things up a little bit and present named features. But there are some things, it may be a user story that just fixes a bug or enhances something that's already there, and that's really fine-grained stuff. But for the most part, people are thinking in terms of larger steps, but you don't want it to be too large a step. You don't want to say, oh, an accounting feature.
Yeah. Well, and
you might want to say the ability to handle credit cards, but that's going to involve a lot of little user stories. Different cards, different merchant banks, chargebacks, invalid cards. To me, these become different user stories.
Okay. I guess I would still try to trend toward, and I understand it's not maybe always possible, but if I'm wanting to process credit cards, I would say, what's the simplest thing that lets us deliver something that the user can use? Well, maybe I can only process one particular type of credit card. Sure. Or PayPal something they want to, and I can do that, get it through, they can start getting value from it. And so
you can do that. I mean, that's a product decision, not a software development decision.
But if the developers are working and I'm listening to what you're saying. I think you've got some valuable stuff. So I will probably be mulling this over. But if the developers are working in units that can't be delivered through to production for the business, I find it's a lot harder for you to have that really intense collaboration of let's leave this out. Here's what we need to actually take a step forward. And some of it depends on the systems, right? You're right. If you've got a new system you're starting from scratch, it's very hard to get to that first story. If you've got a mature system that you're deploying every week to, it's a lot easier to say, hey, here's these stories are independent things that actually mean something to the business.
If you're using, say, example mapping in a Three Amigos process to figure out what your stories are, you're going to end up with pretty fine-grained stories because they're going to cover a few examples typically, and that may not cover some of the error conditions that you want to cover before you put it into production.
Okay.
So I worked for a company once, and the reason one of the primary reasons they were redeveloping the system, well, one, they wanted to get from Perl scripts to Java, but the other thing was they had so many chargebacks against them that Visa was thinking about taking away their ability to use credit cards, which would have destroyed the company. So it was a domain registrar, and it turns out that one of the primary uses of stolen credit cards is registering domains to put malware sites up, because you've made your money by the time this gets reversed. So the crooks can move much faster.
Right.
So there was and the chargeback fees were killing them. Plus, that really upsets the credit card company.
Right.
So one of the things we had to do was put in a feature where there was a delay between accepting the order and actually charging the card. So there was a hold put on the money, but the charge went through later so that most of them would be contested before then. The cards would show up as stolen before trying to charge them, so the charge would fail, because that was much cheaper than having charge reversed.
Cool.
So you didn't want to ship with just the ability to charge the card. and that 3-day delay in a web app turns out to be a little complicated.
You're telling me they actually did ship with just charging the card, and then you were building on top of that to fix problems, right?
Well, no, their old Perl system shipped with.
Oh, okay. Okay. Cool. Well, and George, really looking forward to hearing your stuff on testing coming up. Bill, I see you got your hand up. Let's what were you wanting to ask?
Yeah, I was going to mention, because most of the people doing the estimating are developers, they tend to look things rather focused and kind of very logical, at least the ones that I've dealt with. And eventually there was a lot of angst about being quote unquote wrong. And so I came up with the phrase, we're estimating, we're not exacting, to make them get comfortable. And then and I told them, you do all kind of, explained, you do all kind of things every day where you're estimating and you aren't exacting. And this is just another one of them. And then the other thing was, eventually we came to I found the Q matrix, the complexity, uncertainty, and effort, where you can take each of those characteristics, determine whether they're large, medium, or small. And then based on that, you can kind of fit it into and we use plan estimate points. It can kind of help guide you mentally to that. We don't do it in aggregate. Each person does that individually. And so you might say it's a medium, medium, large. I might say it's a small, small, medium. And then that it kind of equates to a point value. We put those into Planet Poker, and we talk about the differences, why we thought it was what it was. Maybe I didn't take into account the volume and quality of QA work that was needed. And you thought this thing was going to be harder because you've never really done it. But I can tell you I've done a bunch of them like it, and it's not that hard. So it spawns, it helps them get comfortable making an estimate quick.
What you're talking about though is estimate. You're talking about sizing though, right? How big is this
Yeah.
thing?
Yeah.
Okay.
And you can kind of do that in aggregate too with features, if you think about
Okay.
those characteristics. So it lends itself to a lot of things. I found, quite frankly, personally, in my head, I was doing something very similar to this, even though as a Scrum Master, I don't get a vote. I was kind of doing it in my head just to figure, okay, how complex is this? How much testing is this? Do we
Right.
know how to do this? And I was kind of coming up with estimates in my brain, and a lot of the people that I've shared that with found the same thing. They just like that kind of formalizing something they were already thinking. So
Right. The thing that I would what I'm suggesting here with forecasting is the value of coming up with stuff and saying that we can get these, and exactly what you're saying is like, let's make sure these are a reasonable size. And if we can get things to where everything's going to be kind of tending toward a smaller size of similar size, that the sizing you'll have to estimate the sizing like you're describing, but then the actual when will this will be done, the forecasting can probably give you better results on that than what you'll come up with by estimating the amount of time. Does that make sense?
yes, and in conjunction to what I just said, what I do is I go back and agnostically, not even looking at what the group had, the team has sized something. I go back and see how long it actually took in our
Okay.
doing phase. So then I find that goofily, we have Fibonacci 1, 2, 3, 5, 8. And if it's bigger than an 8, we try to cut it up, or if it's an 8, we try to cut it up even smaller. And the cards that are 5s actually take slightly less time than the cards that are 3s. And I think, and I'm just trying to figure out why. Is it because because it's areas that are newer and they haven't explored them, and they have a larger uncertainty factor? And I'm just finding this out with the current team that I'm on. So I use the actual reality to kind of go, I'm going to building a feedback loop to the team so that they can say, hey, we need to rethink the way we're sizing. And so that would also maybe reinvigorate the way we're creating features. My personal biggest thing is and another thing that the POs do with another card added. I didn't,
Right.
I forgot we have Guam, Samoa, and the Puerto Rico that we need on a mailing list. I forgot, whatever. So, and thank you so much. First, before thank you so much for the presentation. It was very, very well put together and very interesting.
Cool. Well, thank you for joining. I appreciate your comments. That's great. I love hearing what other people are doing with stuff. Okay, I see 2 other hands up. I can't tell who they are from here. So somebody want to speak up?
One of the hands is mine, so it's
Yes.
Astrid. And we talk about estimates, and we know it's not a promise, so they can be off in either direction, as George also said in the chat.
Hmm.
And I, as a developer, just see if you are off in the direction that you are faster than you estimated. That's just not mentioned in any way. But if you are off by taking longer than you estimated, you are often questioned why it took you longer and whatever. And because these estimates are taken as promises, and the whole prediction and delivery cycles are based on your estimates. And I think it's very hard to deal as a developer to be off by a certain amount, but the reaction depends on what direction it was. So you overestimate what your time will be just to not be told off.
Right, and I think that is a problem. What if we can move? asking people to estimate when something is going to be done, and I know we can't get away from it entirely, but I think that is problematic because everything, I've got conflicting things, right? I want to tell you I'll get it done sooner, I'm going to be optimistic, or I'll get in trouble if not, and then I'm pessimistic. And either way, it's hard for me to actually get something that's useful to you. That's where I think we're better off estimating the size to try to get things to where they're similar sizes, but then don't use that to predict how long it's going to take to do a body of work. Use the forecasting to say how long it's going to take to do these group of stories. So if I can get 10 stories that are similar in size, everybody looks at it and says, yes, we think these are about the same size. We think they're a similar amount of work. Some maybe, we don't know, some of them may be small, some may be bigger and stuff, but we don't really know exactly how big they, we don't know exactly, but we think all 10 of these are going to be somewhere in the same range. And then I look back and I say, how long did it take me to do the last 10 stories that I tried doing like this? And say, that's probably about how long it will take to do these. Or over the last 6 months, how long has it taken me to do a group of 10 stories that I said were all of similar size like this? Then I can start using actual evidence to say, here's how long I think this is going to take, or the range I think it's going to take based on our estimate of the size. And I think that takes a little bit of it away from the developer to where they're not necessarily as much on the hook for trying to tell you when it's going to be done. They're more on the hook for trying to get it down to a reasonable amount of size. But if they've made the same error in the past that they're making with the ones now, that's still going to be factored into it. I don't know if that makes sense.
Yeah, but your estimate of size is also just a guess. Because if you knew it, you already had implemented it.
Well, but it is a guess. But if I've been guessing like this for the last 6 months, and I'm dealing with a group of stories, like with 10 stories or 20 stories or something like that, I am likely to probably be off in the same way that I was in the past. So if we're dealing with a group of things, they're more likely to converge than if it's just is this particular thing. But that only works if you can get down to something small enough, though, that you can have multiple things instead of just one thing and you either sink or swim.
And if your tasks are somehow similar.
Right. And that's where I think the estimating is really valuable, is trying to say, can I get these things to where I think it's going to be similar size. Some of them you're going to discover aren't. It takes 3 times as long as the size, or 3 times bigger than what you think. Some of them are going to be smaller. But you're probably going to run into, particularly at the beginning of the project, you're probably going to have more of that type of variance. As you move through the project, hopefully you understand your problem space more, and that starts converging some.
Yeah. Okay, thank you so much.
Very, very good point. Thank you. Okay, one more hand up here. Who's that? Okay, it may have been from somebody that dropped. Wait just another second here.